Okay, 3.4. 3.4, we are just talking about it. We're not doing a homework assignment, remember, just going over the big kind of ideas. I want to start by starting at Theorem 310. In this video, we're really only using logic. That's really our only big thing is logic. If two lines intersect to form a linear pair, remember what linear pair is. A linear pair is we have a line and two angles formed from that line. That angle and that angle. Okay? Those are linear pair. Okay, but it says the angles have to be congruent in that linear pair. Well, if we know that those are congruent and are figured here, well, that means we have a perpendicular line. Because those have to be 90 degrees in our linear pair. So, those have to be 90 degrees. That line has to be perpendicular. Okay, moving on. Theorem 311. Okay, I'm not expecting you to remember these exact theorems, but I am expecting you to use logic here. In a plane, if a transversal, okay, a transversal cuts through two lines. We know what transversal means. Cuts through two lines. If the transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. And we really can prove that just by saying corresponding angles, right? This 90 degree and that 90 degree are corresponding, right? And if those two lines are parallel, those have to be equal, right? So J is perpendicular to line H. Well then, if H and K are parallel, J has to be perpendicular to K. Okay. Theorem 3.12, and then I'll move on to something a little different. If two lines are perpendicular to the same line, well then they're parallel to each other, right? Again, these two angles are corresponding, okay, and then they're equal, they're both 90 degrees. These have to be parallel. They have to be parallel. Okay. If you were to get a homework assignment on this lesson, here's really what I would expect. This is from 3.4. I just pulled it out of your book. We're going to talk about it now. This is really your homework, is just watching this video. So, what do we know about these figures? Well, we're trying to figure out which lines are parallel to each other. Which lines? Are parallel. Okay? Question mark, question mark, question mark. Which lines are parallel? Well, let's look at X and Y in number 17. Just X and Y. So ignore line W. We know that V is perpendicular to Y. Okay, but do we know if V is perpendicular to X? And the answer is no. We really don't know. Okay? We really don't know. This could be 89 degrees. This angle here, this angle, could be 89 degrees, not 90. So we really don't know. So X and Y are not parallel. How about V and W? Well, again, if we went to a corresponding angle, this could be 89 degrees, right? Could be just a little different than 90. So in 17, none of the lines are parallel from the information we got. We don't have enough information to say that any line is parallel. Okay, how about this one? 18. Well, back in our theorem, if we have two lines and they're both perpendicular to the same line, right? They're perpendicular to their transversal. Well, then they're parallel. And they're both perpendicular to A, so actually line B is parallel to line C. And if you think, well, they're consecutive interior, they have to add up to 180. Okay, they're not equal. Well, if this is 90, then this angle has to be 90. Well, and this angle is corresponding with this angle, right? So just by that, those are parallel. How about 19? What's parallel with 19? We have Q here, right? And M and N are parallel to Q, so line M is parallel to line N. Line L, we can't say line, oh yeah, actually, no, we can't. We can't say line L is parallel with lines M and N. Why is that? We don't have enough information. Okay, how about P and Q? P and Q. Do you know anything about those two? Well, the only thing you know about P is that it's perpendicular with L. So really, there's nothing else. M is parallel to M. Okay, last one. What do we know? Well, we know that B is perpendicular to C. We don't know if it's perpendicular to D. We know that A is perpendicular to D, but we don't know if it's perpendicular to C. So we really have no evidence to prove that any line is parallel. Okay? That is the big ideas from 3.4. That's really it.